Hello, everyone. Thanks very much for the invitation to speak today. My name is Boyd MORI. I'm an assistant professor and NSERC Industrial Research Chair in Agricultural Entomology here at the University of Alberta in Edmonton, Alberta, Canada. I'm going to give you a brief overview of our canola insect pests here in Canada. I'm sure you're all well aware that Canada is one of the world leaders in terms of oilseed production, with the vast majority of our production occurring on the Canadian prairies. These include the provinces of Alberta, my home province at the moment, Saskatchewan, and Manitoba, with limited production also in southern Ontario and adjacent regions of Quebec. On average, we yield around 42 bushels an acre, which is about 2,200 kilograms a hectare. This is, of course, one of our major crops. It's really usually only comes in second place to wheat, and sometimes can even overcome wheat in terms of total area seeded and harvested. There are several insects of concern in canola here on the prairies and across Canada. There are some regional aspects to this where we have some insects that are more concerned in Eastern Canada compared to the West. These are the major species that I would consider insect pests, but we also have some generalists as well, not included in this list. Of course, given the short time period we have today, I'm just going to focus on three, and there are different regional aspects to all three of these. So we have flea beetles, two species which we treat as a complex, with cabbage seed pod weevil as well as swede midge. So flea beetles, these are two species, Phyllotreta striolata and Phyllotreta cruciferae, also known as the striped and cruciferous flea beetle. These occur across all of our canola growing regions here in Canada. Unfortunately, we do not have great integrated pest management strategies against it. We very much rely on systemic seed treatments. We have 5 active ingredients. The neonicotinoids are our major control strategy, both thimethoxam and clethianidin, with the other active ingredients actually added to a base package, which includes those neonicotinoids. Even if with that seed treatment, we often go and surpass our action threshold, which is a 25% defoliation of the seedling leaves, and the beetles are still present. So if that action threshold is reached, then a foliar insecticide application is recommended. And there we have 7 active ingredients, several pyrethroids, as well as some carbamates, one carbamate, organophosphate, as well as a diamide. In terms of insecticide resistance, there's no known resistance to any of our foliar applied products. However, we do see some increased tolerance of Phyllotreta striolata, the striped flea beetle, to our neonicotinoid seed treatments. This was first discovered around 2006, reported in the literature around 2008. However, subsequently since that time, we're not aware of any ongoing research that has looked into and investigated if there's been a change in this tolerance level. And currently my laboratory has a funded project to look just into that question. In terms of alternative management strategies, these are really just more agronomic kind of best management strategies for the crop in general. The vast majority of our canola is direct seeded, and I forgot to mention that the vast majority of canola in Canada is spring seeded, with very, very limited production of winter canola in southern Ontario. So with direct seeding, it's thought that the microclimate is slightly different. It's a little bit more moist, a little bit cooler, and this slows down the flea beetles and reduces their feeding. We also recommend increased seeding rates, although this isn't always feasible given the increased cost of canola seed. However, this is basically just a dilution effect, right, in which we have the number of flea beetles spread out on more plants, and so you get less damage per plant with increased seeding. Also, early seeding is recommended, in which we can get, if we plant that seed early, we can get the plants through the vulnerable stages, through the cotyledons and those early true leaf stages before we have large populations of flea beetles in the field. However, all of these management strategies are really ineffective if we do have high flea beetle populations. Some things in the pipeline, RNA interference is being investigated at the University of Manitoba, along with some commercial companies there, as well as host plant resistance. Hairy canola, the hairy trait trichomes on canola is being investigated. The original hairy canola in Canada was created genetically modified. However, this new project is looking at using some traditional breeding approaches by trying to integrate Brassica villosa, which has quite a few trichomes on it, into Brassica napus. And that project's being led by Dr. Dwayne Hegedus at Agriculture and Agri-Food Canada in Saskatoon. Cabbage seed pod weevil, this is kind of an annual pest. It's found in kind of specific regions of Western Canada and also throughout Eastern Canada. Here we have an action threshold of 25 to 40 weevils in 10 sweeps. And when that action threshold is reached, a foliar insecticide is recommended. There we have 3 active ingredients, 2 pyrethroids, as well as a diamide, which is actually used in combination with a pyrethroid. Currently, there's no known insecticide resistance, but to the best of my knowledge, no one is actively looking at the moment here in Canada, which should definitely be followed up on. In terms of alternative management strategies, it's counterintuitive to what we recommend for flea beetles, but seeding later in the spring actually can reduce damage by the cabbage seed pod weevil. And here what we see is those fields that are planted early in the spring, those are the first to flower, and those attract a lot of weevils into them. Those fields planted a little bit later, there's more fields for those weevils to spread out in, and you just get kind of, again, a dilution effect, less damage in those later planted fields because there's more of them. Trap cropping has been conducted in southern Alberta. However, it's not commercially adopted, but it is a potential alternative in the future. One thing directly in the pipeline at the moment is looking at a classical biological control agent, Trichomalus perfectus. This work's being led by Dr. Hector Carcamo, who will speak later today from Agriculture and Agri-Food Canada in Lethbridge. This parasitoid is found in Eastern Canada. However, it's currently not in Western Canada. And so it's looking at the feasibility of introducing it here into Western Canada for control. It is being quite effective in Eastern Canada. Also, host plant resistance is being investigated. My laboratory, actually in conjunction with Agriculture and Agri-Food Canada, is looking at some new lines of Sinapis alba introgressed with Brassica napus and the potential for creating some canola quality lines with these host plant resistant traits within them. In terms of Swede midge, Contrarine nasturtii, this is a Eastern Canada pest. Although the acreage of canola in Eastern Canada is quite low, I really consider this a major pest here in Canada because of the detrimental impact and it has had on canola production in Eastern Canada. So this small midge can cause quite extensive damage, and in order to control it, it's primarily chemical control. Again, here the action threshold is based off of pheromone trap capture. The first application of a foliar insecticide occurring once 20 males, total cumulative males have been captured on for pheromone trap within the field. Subsequent applications are recommended, and we have 5 midge per trap per day. And of course, following the recommended intervals between insecticide applications. Unfortunately, this can lead, under really high populations, this can lead to several applications of insecticide throughout the growing season. There's 2 main active ingredients, lambda cyhalothrin, a pyrethroid, as well as chlorantraniliprole, diamide. And currently there's no known resistance to either of these insecticides. In terms of alternative management strategies here, we also recommend early seeding, although again, not always feasible, but here we're trying to get the crop established early and through those more vulnerable early stages before we see large emergences of Swede midge in the field. Crop rotation is very highly recommended, at least a 4-year rotation. In fact, Swede midge populations have been so bad in Eastern Canada that a little while ago, the Canola Growers Association actually recommended a 3-year moratorium on all canola production to try and lower the populations of Swede midge. So this midge is having a very significant impact on canola production out east, and we are worried about its potential introduction here into Western Canada. In the pipeline, there's classical biological control. Dr. Rebecca Hallett at the University of Guelph has discovered Sinopias miles parasitizing Swede midge in Eastern Canada. It's actually now been found in Ontario and Quebec. It's variable in parasitism levels, but this is kind of the first parasitoid that they've found on Swede midge. So they're doing work to see if they can increase this population density in those Eastern regions to help control this pest. Well, that's it. Those were the three major ones I wanted to talk to you today. But please, if you have any questions or comments, I'd be happy to take them. Feel free to send me an email, reach out on Twitter, or hopefully we can chat later today. Okay, thank you very much.